Hi, everybody. I hope you had a great spring break. I'm sorry for the change in plans this week, but hopefully, if you watch the next two videos, this one, and then I'm going to do a separate one on chapter 5, you'll find that you're going to feel a whole lot better about the exam coming up. So keep in mind also that there is plenty of resources on Canvas that allow you to practice. So you will have, if you go into the module, on Canvas, you're going to find a review that is just for chapter 4. I think it's just called Additional Probability Practice. It's all under exam resources. I would really strongly suggest you do that in addition to the review sheet because chapter 4 tends to be the one that people tend to have the most trouble with. Not because the math is hard, but it's more difficult to try to figure out what to do. And I'm hopefully going to kind of go through some of that as I go through this particular video here. Then there's also a review sheet that has chapters 4 and 5. They are different problems that I'm going to go over here because I just wanted to give you a lot of different examples so that you've got a whole bunch of different things that you can use to practice. The exam itself is, I would have to look again, but I think only about 12 questions. Again, though, some of those questions are going to have parts A, B, and C. We'll talk to here about some of the formulas. And kind of mentioning that as I go over chapter 4. So you are going to be given formulas. Again, though, in chapter 4, there's many that I don't even recommend that you use, and you may not use at all. So some of the formulas that you're going to see is that P of A or B is equal to the probability of A plus the probability of B minus the probability of that overlap. And I will have an example in a little bit to show you there. You're going to be given the formula, the probability of B given A, which you're going to use a couple of times, which is the probability of both occurring divided by the probability of A occurring, the given part. And then lastly, you're also going to be given the probability of having at least one, which we've done a couple of times, is 1 minus the probability of having no occurrences, or 1 minus the probability of none. So let's take a look at how all that plays out with some of my examples here. So in my first example, there's 30% chance of rain tomorrow. What's the probability that it won't rain tomorrow? As we go on here, please feel free to pause, write down the problems, really start to look at what I'm doing here. But anyway, 30% chance of rain. So the probability of rain is 0.30. What's the probability that it won't rain? So the probability of no rain is that idea of complements. Okay, it's either going to rain or it's not going to rain. So there's a 100% chance of either of those. So this is simply going to be 1 minus the probability of rain, which is 1 minus 0.30 or 0.70. Okay, all right. Number 2, or the second example here, does some similar, but difference is now we're going to have multiples. So 45% of adults state that their favorite season is summer. Okay, so the probability of it being summer for their favorite is 0.45. We're going to choose 3 adults. I want the probability that all 3 state that it's summer. Well, this is that repetition. So it's really the probability that someone says summer times the probability that they say summer times the probability that they say summer. So it would be 0.45 times 0.45 times 0.45, which you can do in your calculator, but we had also said that a shortcut, this is the one that uses that exponent. So 0.45 to the third, sorry, I did do it on the side here, using your calculator would be 0.09. Okay, so there is a 9% chance that 3 randomly selected adults will say their favorite season is summer. Okay, then the next one is that at least one. So the probability of at least one saying summer, according to my formula up here, is 1 minus the probability of nobody saying summer. Okay, well, the probability that we have is 45% say summer. So the probability that they don't is 1 minus 0.45 or 0.55. So here, 1 minus the probability of no summer is 0.55, but we have 3 adults to be looking at. So again, in your calculator, 1 minus 0.55 to the third is 0.83. Okay, again, feel free to pause if you need to. All right, so let's see, clear all my drawings. Move on to the next one. So here's our tables, which we had worked at quite a bit. Okay, so we've got a table here which shows 4 fast food places and the number of orders that were accurate and the number of orders that were not accurate. Told you before, it's really important. Just take a step back and look at the table first to try to get a feel for what it says. Okay, number 1, if one order is selected, so not multiples, find the probability that the order is accurate or from Burger King. Okay, so we do need some totals here. So again, I kind of went through and did this. So the total of all of the orders is 1,118, adding up everything. So I want the probability that it was accurate. So if I add up the accurate lines, I get 987. Okay, so there were 987 that were accurate, and that includes all of these. And then I want the ones that were from Burger King, which includes these. And that total is 318. I'm going to add the 318. But then we had talked before, this is where we've got this value right here, which was counted in both of those. So we don't want to double count the 264. So we're going to subtract out one of them. Okay, and then that's out of the 1,118 total. All right, so in the numerator, if I do that calculation, I get 1,041 over 1,118, which gives me 0.93. Okay, so that's that overlap. All right, let me get rid of all my circles here. All right, so next one, if one order is selected, find the probability that it's not accurate given it's from Taco Bell. Well, this idea of given, remember, is where it changes the population. Now it's not out of all of the orders, it's just out of the Taco Bell. So it's the probability that it's not accurate given that it's from Taco Bell. Okay, so my population is now the number of orders from Taco Bell. So if I add those, I get 158. That's my new population. So now I just want out of just the Taco Bell orders, how many were not accurate? Well, 13. So 13 out of 158 gives me 0.08. Now, compare that to number 3. One order selected, I want the probability that it was from Taco Bell and it was not accurate. Okay, well, there's no given. So now I'm back to the whole population. The probability that it's from Taco Bell and not accurate, well, that's 13 of them. So this time it's 13 out of 1,118, and that is a probability of 0.01. Okay. And to give you another example of the at least one, I want the probability of at least one from Burger King. That means 1 minus the probability of none being from Burger King. Okay, well, Burger King, the quickest way maybe here is Burger King was 318 orders out of 1118. So that turned out to be 28%. So the probability that it's not from Burger King is 1 minus 0.28 or 0.72. Okay, so the probability not from Boyertown, or Boyertown's where I live. Burger King is 0.72. Again, 3 orders. So we're going to raise that to the third power, 0.63. Okay, really study this. You definitely will have a table situation on your exam. Okay. All right. Now we're moving into what is essentially section 4.4, which was our counting problems. All right, we've got 3 different topics really there. We've got the combinations, permutations, and then the counting principle. Counting principle is what this first one is. College has 5 professors, 8 associate professors, 4 assistant. In how many ways? Let me move my little, well, maybe. I was going to move my little drawing here, or my video screen here. But in how many ways can, there we go, the dean select a committee with 1 faculty member from each category? As soon as you're only looking at 1 from each category, you really are just using the counting principle. So the number of ways is just the number of professors times the number of associates times the number of assistants. Okay, again, the way to identify that is we're taking 1 from each category. All right, so that leaves us with combinations and permutations. Permutations, and I'm talking that NPR, NCR. Permutation, order matters. Combination, it's just random. So number 2, in how many ways can you decide to watch 5 of 9 series on Netflix? Okay, well, you may think that, okay, you don't care which one you watch first, but this is a matter of doing one, putting it aside, doing the next one, putting it aside. So that is an order. So because of that, this is a permutation. The first number is always your total. So it's 9P5. You're going to find that if you switch those, the calculator is going to give you an error. The first number has to be the biggest number. You should know where to find that on your calculator. And then your answer is just 15,120. Different ways you can watch 5 of 9 series on Netflix. And then number 3, pizza place. 3 pizza toppings, list of 10. That you're just putting them on there. Order does not matter, so that's a combination. Again, total is 10 toppings. You want to choose 3. 120 different pizzas. The last thing that I wanted to talk about in terms of chapter 4 is Bayes' theorem. Now, you're not going to have to identify it because it is going to give you, it'll be kind of set up exactly as you see here. You may wish to draw a tree using Bayes' theorem. Okay, so that's where we were drawing a tree, putting down all of our different probabilities. So if we take a look, according to Alvarian, 71% park in the designated lot, 20 in the commuter, 9% in the street. So I've got 3 different categories. I've got the designated lot, which has a 20%, no, a 71% chance of somebody parking there. The commuter lot, which is 20%, and the street, which is 9%. Okay, of those who park in the designated lot, 15% get a ticket. Okay, so 15% get a ticket. That means that the rest of them do not. So 1 minus 0.15 is 0.85. Okay, commuter. Of those who park in the commuter lot, 44% get a ticket. That means 1 minus 44, 56% do not. And for the street parking, 5% get a ticket, which means 95% do not. Okay, so that's your tree diagram. All right, then you've got to figure out the given and the request here. So given that they did not get a ticket, I want the probability that they parked on the street. So the probability of the street given no ticket. All right, so you can flip back to the original or the beginning of this video to see that B given A. So it's the probability that both happened. So they parked on the street and did not get a ticket over the probability of A. All right, so as I look at this, so the probability that they parked in the street and did not get a ticket, well, that is right here. So that is 0.09 times 0.95 over the probability that they did not get a ticket. Well, that's here, here, and here. So no ticket is 0.71 times 0.85 plus 0.20 times 0.56 plus 0.09 times 0.95. Now, I really strongly recommend that you not do this all at one time in your calculator. I would just do the numerator and then separately the denominator. So the numerator is going to give you 0.0855. The denominator 0.801. When I divide that, I get 0.11. Okay, feel free to check my math. Again, I just did this kind of real quickly. So if you disagree, send me a quick email, but I know I have the correct process in case I just made a little mistake in the calculator. Anyway, so that is what you should be familiar with from chapter 4. Again, use the resources, use the extra probability practice, use the review sheet, and reach out with questions. I will be trying to check my emails. Thursday morning, I will be back at it. If anybody needs to meet, I can come to campus early. I just need to know. Normally, I don't get to campus until about 12:15. So, let me know if you need me to be there earlier. And we'll go from there. Okay. All right. Let me know if you have any questions. All right. Bye-bye.